Hey, Science, and welcome to the start of our final unit of the core space exploration, which is Unit E, which is going to be found on pages 366 to page 475 of the textbook. Today, I'd like to start off with topic 1.1, which is entitled Early Views About the Cosmos. We've discussed earlier in this course about how humans have had long associations with different branches of science. We discussed in Unit B with chemistry how people had been manipulating metals for centuries before there was anything known as official modern science. And astronomy is certainly no exception to this rule. By the way, astronomy, when we use the term astronomy, it is the study of anything that is found in space outside of the Earth's atmosphere. Um, there's been a lot of views about the heavens by many cultures in the past. I'll give you a couple here today, and I've got them written here on the board. Some of the cultures that I'll be discussing today before we officially had the official science of astronomy. First Nations peoples of the Pacific Northwest in around British Columbia, Seattle, Oregon, that area, in Alaska. They believe that the pattern in the sky, the stars at night, were basically a great blanket overhead. They believed it was held up by a spinning world pole which rested on the chest of a woman named Stone Ribs. So, an interesting perspective on what the heavens were when they looked up into the night sky. The Mayans of Central America, a very famous, powerful culture that arose in southern Mexico. If you've been to the Yucatan, to the Cancun area, they were that was sort of the hot seat or the hotbed of their civilization. They built observatories like we have today. Here's a shot of the observatory called El Caracal, which was located at a very sacred site, Chichen Itza, on the Yucatan Peninsula. And they basically made naked eye observations of the heavens, including the position of Venus, and made notes of when there were solar and lunar eclipses. So they were monitoring what was going on in the night sky. The ancient Egyptians, a lot of connection with the ancient Egyptians and the night sky. They quite often would align the entrances of their monuments, of their temples, with the rise of certain stars or the rise of the sun on certain days. For example, the temple here of Abu Simbel, you can see here on the slide in front of you, it's positioned so that on October 22nd and on February 22nd, the rays of the sun penetrate deep into the sanctuary. There's like a little doorway there you can see on the slide, and the sun, when it rises, basically goes straight down that passageway on only 2 days of the year, and it illuminates a statue of the pharaoh Ramses II, who the temple was built in honor of on those days, as well as the sun god that's beside him. And there's two sun gods beside him. But the interesting thing is there's a fourth statue in there that remains in the dark on both of those days. Again, just showing how well these ancient architects knew how to build these temples. The one statue that remains in the shadow is essentially the god associated with night. So 3 of the statues get lit up on these 2 days of the year, but not the fourth one, which is related to the night sky. So very interesting there. And these dates, by the way, the dates of October 22nd and February 22nd, you might say, well, it's a random occurrence because the sun always changes position every day during sunrise anyways. But the interesting thing is these dates correspond to the birth date of Ramses II and the day that he was coronated. So they had to plan the orientation of this temple very, very well in order to make that happen. So they had to have a knowledge of where the sun was rising, where the sun was coming up on any given day of the year. So there had to be a knowledge of how the heavenly bodies were moving around the skies. If you go to England, Stonehenge, which dates back 5,000 years, it was designed to track the position of the sun throughout the year, especially important days of the year for many cultures, as I'll get to here right away, were basically known as the solstice dates and the equinox dates, which I'll get to here right away. So what is a solstice? Well, solstice literally means sun still. Sol, sun, sist, still. So it's a day where the sun stops moving. And that's kind of an appropriate term because the solstice dates are basically the longest and the shortest days of the year. They're the days that correspond to the beginning of summer and to the beginning of winter. So roughly speaking, the summer solstice would occur on June 21st. The winter solstice would occur on December 21st. So in the northern hemisphere, the December 21st is the shortest day of the year. And if you note, what happens is the sun, every day when it rises up to about December 21st, the sun rises a little bit further to the south. And then as the days get longer, the sun begins to rise further and further to the north. But on the day of the solstice, it's sort of when that movement ends. So on the solstice of the winter solstice, the sun continues to move south in the sky every day, a little bit further south when it rises. And then on the day of the solstice, it actually stops moving. And then it begins to move in the other direction, starts moving more toward the north until it hits the summer solstice, which is the longest day of the year, when it reaches its northernmost sunrise point on the horizon. Again, it then stops its journey and then begins to move back toward the south. So the solstice name is quite appropriate for this longest and shortest day of the year, which again correspond to the start of both summer and winter. Be aware, in the southern hemisphere, it's exactly the opposite. The winter solstice is not December 21st in the southern hemisphere. The winter solstice in the southern hemisphere is June 21st, and the summer solstice is December 21st because the sun during the winter moves more toward the southern hemisphere, as you can see in this diagram, because the Earth is at a slight axis as it rotates around the sun. So as the Earth's axis points away from so in my head right now is the sun. There's the sun. This is the Earth here. Right now, here's the northern hemisphere pointing away from the sun. So this would indicate that the northern hemisphere right now is in winter. The southern hemisphere is pointing toward the sun. So it's basically having its summer. Well, and if the Earth travels around the sun and goes to this point over here, if I can get my hand into the right orientation, there it is. Now the northern hemisphere is pointing toward the sun. So we've got summer in the northern hemisphere, but the southern hemisphere is now in the winter because its pole is, the south pole is pointed away from the sun. So the days in the southern hemisphere are shorter when the days in the northern hemisphere are longer, and vice versa. So if that's a solstice, then what's an equinox? An equinox literally means equal night. Equa, equal, nox, night. Well, equal day and equal night occurs twice a year. On the spring and the fall equinox dates. So this would be March 21st and roughly September 21st, when there is technically equal amounts of night and day. It's literally the point of time where you have the Earth is sort of, if this is the summer here for the northern hemisphere and this is the winter over here, I can't do my hand. I have all sorts of jokes. Let's try it this way. Here's my Earth pointing away from the sun. So this is now the winter for the northern hemisphere. If it goes over to this side, now it's summer. Well, the equinox date would be when it's about on this in front of the sun. So now the sun, there's equal amounts of sunlight pointing on the northern and the southern hemisphere because the Earth is sort of at an angle where the entire Earth, both north and south, are receiving equal amounts of daylight. So those would be corresponding to the beginning of spring and fall. So in the northern hemisphere, just to recap, you've got two solstice dates, which are the longest and shortest days of the year. That would be the summer and the winter solstice. Summer solstice would be June 21st, and the winter solstice in the northern hemisphere would be December 21st. In the northern hemisphere, we also have two equinox dates, which are the days where the night and the day are equal in length. These are going to be your spring and fall equinox dates, which are going to be March 21st and September 21st, respectively. In the southern hemisphere, both the equinox and the solstice dates are flipped. So in the southern hemisphere, the winter solstice would be June 21st. the summer solstice would be December 21st, and in the southern hemisphere, the fall equinox date would be March 21st, and the spring equinox date would be September 21st. But these are very important dates. Getting back to the whole reason why we're discussing this, these are very important dates because this would allow ancient cultures to know when to plant their crops. They would know it would give them kind of a sense of how long the year was before maybe official calendars were made. Now the Mayans based the calendar on the astronomical rising and setting of the sun and the position of the stars. So there were some cultures that actually were able to basically track time using these dates of the year. And it gets pretty crazy. If you ever have a chance to go to Chichen Itza in the Yucatan Peninsula, if you're ever in Cancun, I would really recommend you go to Chichen Itza. It's one of the wonders of the world. There is a temple there known as El Castillo, which means Spanish for castle. And on that castle, you can see it here on the diagram. Here's the Castillo right there, and then there's some pictures of the base of the pyramid there. It's a pyramid. It's a pyramid with a temple on the top. And I'm just going to read off of this slide just so that I don't get everything wrong here. It's a four-sided pyramid. Each side has 91 steps. Combined with the platform at the top, that totals to 365. That represents the 365 days of the year on that temple. So they actually built the temple around the days of the year. Now here's where it gets even crazier. As well, shadows cast during the equinox creates a golden serpent that glides down the pyramid as the shadow creeps down the pyramid. But it only happens 2 days of the year. The temple is, or the pyramid is arranged so this will only occur on the equinox dates when the sun is in the right position in the heavens, when the sun is actually I'm not sure if it's a sunset or a sunrise. It doesn't have it here. I'm so sorry I don't have that, but it's basically this event with. If you Google it, if you type in Chichen Itza serpent shadow on YouTube, there's all sorts of videos of people who have posted. There's people that come from all over the world to see this shadow that comes down, and you can sort of see the shadow on the. You can see it right here on the pyramid. You can see a little ribbon of light that appears there. Now, judging by where the sun is there, that to me looks like it's a sunset. So I think the actual shadow drops down at sunset rather than at sunrise. But again, they have to know where the sun is in the heavens to arrange the pyramid in that orientation to make that happen. So this really shows that these ancient cultures, even though they didn't have official branches of modern science like we talk about today, they had a very good understanding of positioning of astronomical objects that were in the sky, whether it was the sun or the moon or stars in the sky. So very interesting. But again, these dates, solstice and especially equinox dates, would basically allow ancient cultures to know when to plant crops. So they were very important dates that were measured, whether it was by the Mayans or by the people who built Stonehenge. A lot of cultures used methods to measure this stuff in the sky. Well, modern astronomy sort of dates back to the ancient Greeks, even though the Mayans were around after the ancient Greeks. The ancient Greeks sort of kind of brought the modern to, I guess, astronomy, if you want to call it that. But we've talked about a gentleman before by the name of Aristotle. And once again, Aristotle got it wrong. He got it wrong with chemistry, where he said that all substances were made up of earth, air, water, and fire, rather than distinctive particles like little atomos, like Democritus had said. So once again, Aristotle, being the very popular philosopher that he was in Greek history, became a very big proponent of a theory, and then everyone believed it. He believed in a theory called the geocentric theory of the universe, or the geocentric model of the universe. He believed that the Earth was in the center of the universe. And this theory was backed up by a Roman scientist by the name of Ptolemy, and then this basically dominated astronomy thinking for, again, 2,000 years. He basically set back astronomy by about 2,000 years until some people began to kind of challenge his way of thinking. Now, it is interesting to note that when Aristotle made his theory about the geocentric universe with the Earth in the center, there were other Greek scientists that weren't as maybe well known, as popular as Aristotle. One of them was named Aristarchus, or Aristarchus of Thamos, he proposed that it wasn't the Earth that was the center of the universe. He believed that the sun was the center of the universe. Now, we know the sun isn't the center of the universe, but from our perspective in the solar system, the sun is in fact the center of our solar system. So there were Greeks that actually had it right, but again, they were sort of pushed to the side by the more popular view of the famous scientist Aristotle. And so guys like Aristarchus, who basically came up with the right theory, their theories got pushed to the wayside for about 2,000 years. And one of the first modern European scientists to sort of kind of resurrect that view was a guy by the name of Copernicus, a Polish astronomer. And if you want to watch a little bit about Copernicus, very interesting fellow, but he was sort of the guy that resurrected the whole, the sun isn't the center of the universe. The earth isn't the center of the universe. He believed that it was the sun that was the center of the universe. So rather than being a geocentric model of the heavens, he believed in what was called a heliocentric, helio meaning sun, centric meaning center, so a sun-centered universe. And his theories were backed up at the time because there were some new inventions that basically came up at that time. Sorry, as Siri kicked in there. He also, his theory was backed up by, I see what's happening. I'm saying the word theory, and she thinks I'm saying that's what's happening. So I better not say that word because she thinks I'm talking to her. So his belief was backed up by new science and new technologies of the day. One of them was the telescope. The telescope was invented roughly at the beginning of the 15th century, around 1602. The telescope was invented, and it wasn't long after that a scientist in Italy by the name of Galilei, basically came along and basically began using the telescope to back up Copernicus's theories. Copernicus went to his deathbed, basically believing his theory, but no one else did. And Galileo then came along and basically said, "Yeah, I think he's got it right. You know, the sun's in the center of the universe, and then all the planets and all the other stars sort of circle around the sun. And they're nice circular orbits around the sun." And he was able to support that theory by using the telescope. Galileo discovered a lot of things by looking at the telescope. He discovered that Saturn had rings. He discovered that Jupiter had moons. At that point, we only thought there was only one moon, and then all of a sudden we realized that other planets or other objects in the stars or in the heavens actually had moons of their own. So how could there be moons circulating around Jupiter if the Earth was the center of the universe? Why would there be objects circulating around Jupiter? Should they all be circulating around the Earth? So that really led Galileo to believe that the Earth wasn't the center of the universe. And what did he get for his trouble? He got house arrested. The Catholic Church did not really take well to Galileo's theories. He basically was put under house arrest, told that he couldn't publish any more books. He had to publish some books in secret. He had to smuggle them out of Italy. A Dutch publisher would publish some of his works after he was under house arrest. And the Catholic Church did not officially acknowledge the error of them, punishing Galileo for his theories. It wasn't until 1992 when they actually pardoned Galileo because they believed that originally when they house arrested him, it was because that his theories of the heliocentric universe were considered blasphemous, that it was against what the Bible had said, that the earth is the center of creation and the center of the universe. So there were two guys that sort of kind of got it right and began the real process of steering astronomy in the right direction. That was then supported mathematically by a German mathematician by the name of Johannes Kepler. He came along and refined the heliocentric model. He found out mathematically that the orbits of the planets could not be circular around the sun. They had to be elliptical, so they'd be more like ovals around the sun rather than. So he believed in these elliptical orbits around the sun, whereas Copernicus and Galileo believed that they were perfectly circular. but through math and calculations there was another astronomer that he used the calculations of. He was a Danish astronomer by the name of Tycho Brahe. And Tycho Brahe, crazy guy. Watch this video. This guy, I'm not even going to give it away. Just watch the video. The guy, he lost his nose, and you'll never know how he lost his nose. You got to watch the video. I'm not even going to tell you. We'll just watch it. But this guy was a real crazy guy in the annals of science. Tycho Brahe, I like just even saying his name, but Tycho Brahe did a bunch of observations over years, and Kepler was able to use Brahe's observations through telescopes to basically mathematically predict that the planets were moving in elliptical orbits rather than circular orbits. So very, very important that he made those mathematical calculations. Even though Kepler wasn't an astronomer, as a mathematician, he was able to kind of calculate all that stuff. That's our conversation for today. For homework, I'm going to get you to do questions 1 and then 3 to 9 on page 376 of the Science in Action 9 textbook. Next day, I'm going to be walking you through the discoveries through technology. I discussed a little bit about the telescope today, discussed a little bit more about telescopes next day, and how those inventions led to this revolution in astronomy that I just talked about today. Thanks for tuning in, and we'll see you next time.